Hello everyone, today we start learning some C++ basic syntax, and at the moment I would like to introduce you and we start learning what does it mean, the class, the header, virtual function, composite design pattern is the main goal for today. And also we try to look into the CMakeList.txt file, how the structure looks like, and also we have the interface, abstract class, etc. And for the start, I would like to show your tasks free, and for our goal for today is to implement freely chosen data structure unique algorithm. Freely chosen data structure, we use maybe the list and the basic composite design pattern. Idea is to create the tree data structure also, and we using the list and we using similar to the tree structure when we create composite design pattern. And when you have some software, sometimes there is some build tools or build systems, and CLion by default have CMakeList.txt files. Some another software maybe has some makefile or different implementation. Also, this helps you to manage your project easily. When you have some added dependencies for libraries, for files, it automatically knows that this project has some files and libraries and etc. And basically, CMakeList.txt file contains set of directives and instructions describing the projects or files and targets. For example, if you have some main C++ file, when you have some headers and other stuff, you're able to add in a single line. We later see in the example. And it helps you to manage your project easily. And when you create a new project, it automatically generates CMakeList.txt file and places to the root directory. Okay, when you try to open the project, you're able to choose the CMakeList.txt and open the project, and you will get your configuration. Here is example how it looks like some Hello World project. You have CMakeList file, and here you have CMake. If you know what does it mean, the make files or another type of files. In Makefile, you just added some resources, header files, C files, and compile into the project, in the exe file if you're using Windows. And here you show your version of CMake. Project is create project simple example. Set CMake standard. You're able to control your C++ version. If you would like to change, you easily add a new number like 17, 20, and you're moving to the newer version. If you would like downgrade, you're able to downgrade to add it 11. And also you see the set add main C++ file to the project root directory as source file. Able to create a variable set command, set instruction, and in source file you running you're saying that here is a executable files, you need to compile this file, and here you added at executable name of project and a variable source files. Able to add more than one file if you have the project, like we today try to create the project with multiple files. Okay, now let's move on to the next slide, and here I try to represent as much easy to understand why we need those header files and why it's better than write the spaghetti code or in the single file to write all code, like different structures in the same file. Better it's to use a separate files and easier to manipulate or work with that data. And when you have headers, when we working in the team, you always need to share your project in this, or divide the project into small parts, and you would like to have some separate files. For example, your colleague John would like to work with some sorting algorithm and would like to implement only sorting algorithms and have the file sorting or algorithm. Another colleague would like to implement some graphical user interface. Another would like to use some different implementation, and better to divide into different or separate files. When you work in team, it's not possible to work in the same file. In the single file, it's easier to share your works job. And when you need to use the same function twice or more, it's not possible to use it if you have the simple implementation. When you implement some function in that file, you're able to use only in this file. And of course, you're able to implement the class, but it's complex to read it, those functions later. Of course, is it possible to use this function in the same file? But if you would like to use in separate C++ files, it's really not possible. Or you need to just copy-paste your declaration of function and then use it. To copy function declaration is really bad practice. And header files, header files have the general place where it stores the basic function declarations. You need only add a single line include header file, and you're able to use this function. Function implementation doesn't matter which type of function, but we'll later see. And also divide complex project. For example, you have a big problem and you need to divide into smaller problems to solve this problem. And for example, you know some theory, there is divide and conquer. It's also from the structural programming when you creating the functions. It's also divide and conquer, to divide in small parts and so solve problem. Like that reason it's used to headers. Easier to maintain and update code, etc. And of course, C++ is object-oriented programming. And when you have some objects in different languages, for example, in Java, you have the separate file that represents concrete object type with a name, like you're creating the person file, and that's it. In C# is also you're able to create a class. You don't need to create the headers, but in C++ you need to create the header files. And that's the biggest difference between those programming languages. And for that reason, of course, C++ it looks like the first exotic language and hard to learn, hard to understand the keywords, like you have the friend, virtual, etc. Like really hard to understand at the moment. But when we have the headers, you added a bit boilerplate, or just some declarations, and separate from the implementation of function. And when you look in the function implementation, it's really a lot of useless, not useless, but it's some code. It's hiding in your header file, and easier to read the C++ file. It's not so complex because a lot of keywords it's hidden or added in the header files. Of course, here is my opinion, but you will see later why I'm saying this and why it's easier to reading when you try to compare with Java, C Sharp, or other languages, which is all implementation added in the single file. And for example, we need to create the header. In header, you need to add only declaration, not implementation of the methods and constructors, functions and constructors. You don't need to add implementation. You just added that this function exists, and compiler knows that this function exists somewhere, and for that reason, able to use this function in any file. You need only to add it include and header file name like person h if you're creating person class. Why it's I recommend to create the same file name, because you know that here is object person, and in that person h you will find the person object. Objects, it's really same. Maybe we later see the difference between structure in the C language and difference between the class. It's really not a big difference, because it's only in C++ classes you will find the new keywords like private, public, protected. Those means accessors or access modifiers, which is helps not let to this class person would like to hide some data, to share some data, or to share some data with inherited or child classes. And if you use if and def, you don't know what does it mean, and you always need to add like this. Some different compilers have pragma once instead of this if and def define, and that means here if it's already defined this code. For example, if you're using in the single file include person h and using again multiple times, you don't need it's automatically copy that same header file. It's used not multiple, but using the single source, like single h file. When you adding the 10 like includes in your separate places, you're using only the same file here also. It makes virtual copies of this std name, int get id, like these declarations in the code. And when you're creating the class, you need to write a class name, private fields. By default, always is without the private keyword, it's also private. Public means that this function, it's get id, it's public. And protected means that child class is able to use this, able to inherit this field. Private fields only in this class scope. Okay, now we're moving to the harder part. When you're implementing your functions, you need some inclusion in your file. Like in any C++ file, you need to include person age. For example, if you're creating the person age file, and then we have, as you see, the single not implemented getID functional method. And how to implement, you need to use double colon symbol like this, and on the left side you see the class name. This class, you need to say that from the person class we implementing getID method, and this getID is accessor to returning ID. That's it. And as you see, we using ID is a private. And how we able to use this ID? We just add it to the header file. Because we added here a header file, we're able to use this person age file. And as you see, we're able to implement functions, getID, added double column. It's like always class name. If you have the constructor is also the same as a class name, you also added class name, same to twice. Like person will be the constructor. And then you're able to add parameters if the function or constructor have, and you need to add statements. Statements, any type of statements here, it's like returning, some calculating, algorithm, etc. And of course, if you have some destructor, you need to add some symbol here, also same as a constructor. We'll later see in constructors. How to use it? You must include person age. You don't need to include person C++ file. And you creating object first. Object instant person get ID. And it's working like intended. Of course, don't forget to add those created age and C++ file to your source file place. Sometimes when you're creating the in CLI in the classes, it's automatically adding if you choose the option target files. But if there is no target files, you will get some undefined reference problem. And I would like also, before we start, show some difference between the structure. We have C++ class versus C++ struct. By default, our fields are public. When you have some structure human, you're able to string name, int ID. If you're adding the methods, it will be the public by default, and it's not possible to hide because the C language was structured as a record. More the record than the class. But of course you're able to create a person class. If you're creating the person class, you're able to add some fields, which is by default is not public, it's private, because when you have some more than one file, you would like to hide some information from others, because person did, or not person, maybe the bank didn't want to share the password or account password or some information, and some fields should be hidden. Of course, you have terminology like encapsulation, data hiding will goes here, and you're able to hide the data, like to create private fields and to share the data using the public fields later. It's like encapsulation term. and here you see the public. Public it's same as structure, and you public functions. Double it means profit you're able to share with your inherited or child classes. Difference: by default all fields public. By default all fields is private. Public access anyone. Protected reach only derived or inherited child classes. Private only use in the same class implementation. Like in the class person able to use your private fields. Like we have the ID, it's also private, but we using the person scope. In person scope we able to use your ID, doesn't matter it's private or not private. For that reason we use private fields. And now the hardest part, when you have some interfaces and abstract classes. In the Java or C# languages, you will have the separate keyword interface and abstract classes. In C++ world, you didn't find this. You find some compiler warnings, errors, but you need to know that when you need to create some abstract class, you need to create pure virtual functions only. And here I would like to show the basic example of virtual function. Later I show another example how to create interface, how to create interface and abstract class, what difference between those and how to use it. Virtual function, when you have the base class and you have the public field method 1, method virtual method 2. By default, this method will be in the base class. As you see, the base method 1, it's the base implementation of class, of base class. If some class is deriving or inherits from the base class and use the same method, by default you calling this method 1 implementation. Doesn't matter if you have the same method and different implementation, you calling the base class implementation. And here is a problem if you would like to override your method. In C++ world, you need to use the virtual keyword. That means if you not implemented the method 2 in your class, derived class, it will take the default method. If you write if you implement in derived or inherited class the method 2, you override this method. And as you see here, we get method first without a virtual keyword. It prints base method 1. Doesn't matter if we have the derived implementation, because it comes from the base class. We adding the colon. Public base means that we extending or inherit base methods. And when we have the virtual keyword, you will get some derived method 2, because you override this. In C++ 11th standard, it's more easier to understand. When you're overriding, you're writing override here, like override keywords. Later we see. Okay. And now we're moving to the deeper and to our main goal today. and we need to implement composite design pattern. And theory I take, I don't know, from Wikipedia, maybe doesn't matter which source. And why I added this? Because you need to understand why we need to use this, because it's hard to explain at the moment. And later when I show the diagram, which is I created as example, and as a basic structure of composite design pattern, it's structural design pattern and helps to solve some problems. Sometimes easier to implement this pattern. Okay, problems composite pattern solve. Part whole hierarchy should be represented as a tree structure. If you would like to create some structure, which is half tree, half list, or I don't know how to explain it. It's like part whole. That this explains why this term is added here. So part whole, be able to create like tree structure, the full tree structure, or to create a tree but not a tree. Like it's like hierarchy. The structure with a hierarchy. It's like a tree. Really hard to explain this, because here it's when you look into the graphical representation and have more objects, you see as a tree, but you're able to use as not a tree, it's like as a list. You don't need to write a recursive function to read the data. Later we see the example and understand what does it mean. This tree or not tree. What solution does composite design pattern describe? Define the component interface. For that reason we need to understand what does interface. It's only abstract functions which is implemented in different objects. For example, we have different objects like leaf. We would like to say the leaf is component, and the composite, for composite pattern you always need to have the composite object. Later when you understand what does it mean the composite, you're able to use your own names, like you have component like object, you have the leaf, I don't know, it's any item of object, and composite is like list of items. Doesn't matter, you're able to different names to use it. Here is a basic composite design pattern theory and usage. You have the component, its interface, you have the leaf, and you have the composite objects. And you're able to use this composite, as you see, root class is yellow, composite object is like green color. Composite objects means that you will have some subtrees inside your composite objects. The leaves is only the instances of component. Instances of component is leaves, and also you have the list of components, which is also composite is also component in the same type. Like you have the same type composite objects and same type is leaves. And here we have like a tree structure, but of course not balanced tree, and I think that it's not possible to balance this tree because here it's a bit different. It's like here you have some hierarchy. It's like a tree structure. You're able to use yourself nicer or not so deep tree, but sometimes it's really hard to create that structure, because you need to have cabinet, motherboard, maybe deeper, or that side you need maybe less elements, and it's not a basic goal. It's to implement the tree. If you implement the tree structure, you're implementing the tree structure. Here is a composite design pattern idea to group your elements, and when you need it, for example, peripherals, you're able to call it directly using peripherals. When you need a motherboard, you're able to call motherboard components. And if you need a single element, you're able to call only HDD or any. Later we look in the implementation and example, we understand why we call the component and composite. And here I added some colors only for output, for understand which type of composite. I use the C library, Windows H. And here is a single line to init console and to add color. Here is a color table. Okay. Now we need to understand what is the interface. We're creating new project. I'm creating C++ 14. We're creating composite example. Okay, we have the project. Waiting few seconds. To finish our project. Where is a warning? There is no warnings at the moment. As you see here, we got makefile 3.15, project name, standard, and add executable main C++. When we're creating more files, I'll show you later what happens here. Okay, first we need to understand what is interface. Later we moving to implement composite design pattern. In Java or C# you write interface. Like you're creating the functions like interface name, I don't know, component, and you're implementing like void show price. You implement it like this when you have some Java or C#. It's like only abstract methods which should implement it in other classes. In C world, you need to implement like this. Implementing class as always the same component, and you adding method virtual void show price. And here of course you need to write as a pure, it means abstract pure virtual function. That means here it's interface example. Interface is also abstract. Can't instantiate. You can't create the instances of this class. If you here it's C#, I let here C# or Java. Okay, if you try to create a component, you will get the error here. Variable type is an abstract class. By default, interface it's also an abstract class because you have abstract method, pure virtual function, and here is like interface. If you need the class, you're able to add some other class C, doesn't matter. We have virtual void print equals 0, and we're able to add void A. Here is C# or Java abstract class. When you have some abstract methods and you have some not abstract methods. Here is difference between the Java or C#. You don't need a new keyword interface, and you're not able to create the instances of C or that. It means the same, it's an abstract class also. There is no interface, so abstract class is abstract class because you have abstract fields. And why we need this? Sometimes we need to say that my class flower extends its colon symbol, extends to inherit from the some another class. You need to copy some fields or to get some basic implementation, able to add colon, and you need to add a public because you need as a public class extending component. And when you're extending this, you say that flower is component. Flower is component, and when you use the flower as component, you're able to create a collection, and for example, able to also say that here is also component. And of course, you need to implement this virtual function, which is pure virtual. Is abstract function you need to implement here. Maybe here, of course, you need to add public because here is a private. Public, and here you need to implement your function. Show price, and I just copy here also here. Show price, and you're able to manipulate, not manipulate, you able to create your structure and say that your component should always have the show price method, or your components as buttons, text fields should have event, some on click event maybe. And here you have flower and seeds also have different implementation. And here, of course, you don't need to add a virtual. It's you when you're overriding the function in the older before C++11, here using this virtual keyword. Now you're able to use the override. After the method, you're able to add override here, and you're able also add override because you're overriding the component method and you're creating your own unique implementation. For example, we need include using bad practice, using namespace std. Better to use std for all fields, like writing like this, std cout but for demonstrate purpose I use without std. Cout, use the flower, and here we use a cout C class. As you see, we have different implementation, and now you're able, as you see, create objects. Flower, show price. Flower, as you see here. You get flower and you get C show price, or here. Var public. Maybe here is a problem. Yeah, and we see C class and flower here. We'll get output of those. As you see, you say, what difference? You use component, implement this, and why you need the component class if you're able to use the same method. But this helps you to have that flower and C class is also the component, and to be able to create the list of components, list of components, because you need to include, we're using the STL standard list implementation. It's like a dynamic array. And here able list of components, push back C, private. Where it's private. Sorry, here you need to create public. Yeah. Don't forget to add a public, because if you're not adding here keywords, it's like inherited class as a private and not able to use outside, like we saw now. Push back, flower. We're now pushing into the collection of component, as you see, not a flower, not a C. And why is good? Because you're able to later to iterate through the component, maybe list of components. What's wrong? Sorry, it's abstract class now. Maybe you need to create references. Auto. It means that automatically adds the type. Auto C equals new C. Let's try like this to make, is it any difference? Because we need as a reference now. Auto as a flower equals new. We need to create new flower and new C object. In C# you don't have this asterisk symbols on Java, and here it means like also able to add concrete type, but you're now able to read your references to this object. And now you're able to only print it com.showPrice. Sorry, you don't need to print it, also printing. We're able to call this collection and we get the same result, and we have the collection of components. And later we see some implementation of the composite pattern. And lecture before I failed a bit on the static keyword, and when you have the static keyword like this, I don't know, maybe in some class, static int index, for example, you always need to implement your index outside, like flower index int flower index equals 1. Here it's a big difference when you need to initialize your object index. You should initialize outside the class scope, because the class scope static works a bit different. And you see int flower index equals 1. And when you try to use, you're able to call it flower index, or just try C out. Here is a for static working. Static keyword output. And you see here static keyword output, it's 1. You're able to change flower index plus equals 4, for example. And you get 5. Yes, here is a big problem before I start to show your static keyword. And if you need to use the static keyword, you need, if you have the class scope, you need to implement outside the class scope your static fields, to initialize the static fields outside. Not able to add like this. As you see, you need to add here. And when you have a programmer like C# or Java, it's really hard to understand why you need to add like this if you're able to add default value like here. But you're not able to do this, you need to implement outside. Okay, here's for static. And now we have the latest part of our main goal, to create composite design pattern. And as you see here, we have the structure. It's a basic structure. If you have some computer store and would like to show, I don't know, I'm just open some store and I open any, I don't know, the item, and maybe I need a laptop, computer, and in notebooks, yes. And our goal, when you have some structure like this, here it doesn't matter which, maybe translate to English. Okay, that. For example, you have product details. And I, as a consumer or client, would like to see not this huge list here, it's really hard to understand. Or not hard to understand, but it's really hard to find what I needed. Sometimes if I needed to find some, for example, hard disk, but there is no prices here, as you see. And who cares which software, which components added without the price? I got the final price, and I don't know how much it costs concrete elements here. Like how much costs operating system, how much costs our SSD, and etc. If I would like to make some upgrade or some downgrade and other stuff, I'm just try to make our configuration. And for example, I would like to get all filters, like to get all components, to get only hard disk, or to get only the external, internal, and to get the price, to have different filters, like to get group of objects by category, for example. And composite pattern helps to do like this. You're able to choose and to create the structure, and you will get the component total price, half price, concrete elements price if you need. You're able to filter how much components you need, that much you're able to pick that subtrees, like. Okay, let's try to do first the basic implementation. Here, when you have the computer, you have the cabinet, you have peripherals, motherboard, and etc. Okay, we're creating maybe, or just deleting this implementation here and deleting here. We're leaving only the main. And when you're creating your best practice to use header files or different files, you're creating your, for example, class. At the moment, when we're creating the component as an interface, we don't need the implementation. We're using the only header file. Component. And here you need to write like class component, and as you see, if and if define, you in that field placing your component implementation. Virtual function, void, maybe we create show price or show details, maybe. Show details, it's pure virtual function. And also we create another virtual function later. We're creating at the moment this function, and later we added more functionality. And when we have some component, show details, we need another object, the C++ class, be able to create from template, creating automatically C++ and header file. And here we're creating the leaf. As you see, we get H file, and C++ file is empty at the moment. And in CMake list, you will find component leaf added. Okay. And here we need to extend or say that leaf is component. Public component. And here we need to include component H, because we use the component object to get this virtual function. So you see overriding something. And here we're creating public fields, creating void show details, overriding, and also we're creating the private fields because we need to have some data. Leaf have some string, std string, name, and we have double price. Yes, and we need of course add it, include IO stream maybe. Yeah, include IO stream and enough. And here, as you see, we created the header file and basic structure, and we need to implement show details. And we need to also create constructor. I recommend to use the generators to automatically generate constructor. Alt insert and press constructor and pick your, with control key, those fields which you needed added to constructor. Okay. And as you see, automatically in header file, it's adding leaf. That means creating the constructor of the leaf. And in H file, you will find the leaf added, not implemented. Here it's like declarations. And also we need to create show details function. Alt enter, generate definition for function. And as you see, we're creating void leaf show details. And here is your std cout, cout show details. We showing output of name and price. Name, and maybe we're adding separator, name, price. Euro. Euro and std and line. If you're adding in your H file libraries, you don't need to add it here. Like here. If you're adding here, you don't need to add in C++. More. It's easier to read it now. It's easier to read it your C++ implementation file. Less boilerplate from here, as you see, class, public, keyword, etc. You're reading only your useful information. And here is implemented leaf object creation and show details to show name and price in euros. Now, as we see, we have a leaf. We able to create HDD, RAM, CPU with some properties like price only. And now we need to create the composite objects like green one. Composite objects is, as you see, with a structure. Like composite objects, able to hold another composite object or to hold the single leaves. Or just to have composite objects which just have also the leaves inside, etc. Like you have the structure, list or group of element structure. How to reach this goal? You need to create a composite class. Composite. And when you're creating composite class, you need to extend component. Public component, include component, and public void show details, override. We creating constructor. We don't need empty constructor. We creating the private fields first. Std string name of composite object. And IOStream. Also we need the list of elements. List. Std list of component of references of components Okay, and we have the private, and we need a public method, which is add some component to the composite object list. Add component. Yes. And composite objects able to hold another composite object and able to hold leaves. Leaf is component, composite is component. You're able to add any component. Composite or leaf. Now we need to create our constructor. Alt insert, and you see, oh sorry, also we need to create constructor only with name, because we need only the name of composite object, and we need to implement also those two functions: generate composite show details and add component also here. And as you see, we have two functions to need to implement. First, add components easier to implement, like components, push back components. That's it. You're able to add. You're adding or appending components list with a new component. Doesn't matter, it's composite object or leaf object. And here you're just showing some details. We taking component C components, and here we calling show details. Private member. Okay. Why it's private? Oh, public. Now we see difference here because we need a public function, not private. Yes, and composite show details should call the whole list, and to print it, not print it, to call the show details. And here we're able to add components. That's it. Composite pattern is implemented. Now we need to output some information. And maybe it's like this. We need to include component H. And now we need to create our computer, cabinet, peripherals, motherboard. You're able to use auto keyword. I recommended to use it because it's easier to know that which type you need it on the left side. Because in C++11 standard, you're able to use auto keyword. Auto, here I say computer equals new composite. Oh, maybe include composite. Include leaf. Oh, doesn't matter. Del Inspiron and auto keyword. We using peripherals, composite, auto cabinet. I think that is cabinet. Yeah, cabinet peripherals. Cabinet peripherals motherboard. Cabinet. Oh, sorry. Auto motherboard. Yeah, it's a lot of work to auto. Okay. Now we need to create our leaves. Auto CPU leaf. Intel E7. Price 500. Auto RAM. RAM Corsair. CPU RAM we adding the peripherals, maybe auto. Let me just copy this. Mouse. Razor. Razor. No. Mouse keyboard. CPU, HDD. Maybe it's enough for our goal. We have computer and we add components. Component adding peripherals. Computer add component adding cabinet. Or not cabinet. Yeah, cabinet. And then cabinet would store motherboard. Like you able to do like this. Motherboard, computer, cabinet, motherboard. And before this we need to add fill the elements like peripherals, add components, mouse, peripherals, add component, keyboard, and CPU RAM we're using for the motherboard, add CPU, motherboard, add RAM. And why it's good to group like this? At the moment, of course, we can move it other object. And when you calling the function, for example, computer show details, what happens here? And you will get peripherals. Oh, maybe we lost some stuff to print it. Composite, we need to print the name. std cout name. std cout name and line. when you're printing peripherals, you're printing like the name composite, like the computer, peripherals, cabinet. Of course, I have some time, and maybe we add some colors and implement some another object and another composite method. You need to include Windows H here. Maybe I include it here directly and to use this implementation also here. This one copy for faster. I don't add it to the header or a separate class, just use it here because it's easier to make it. And here we need to add set color like blue one. Okay, white storage duration may throw static storage. Let's try to run it, I don't know. Oh, it's all components. Maybe we need to add this color also to the leaf. Better is great. As you see now, we should add it here and here. Better to create a class to add the colors. And because you need to include Windows H everywhere. And we use maybe color 2. Oh, multiple definition, maybe it's already implemented. Oh no. Better maybe to implement. Okay, we try implement a color. Then we remove this. The color class, new C class, color. We have some public and create static set console color, adding int color, and we just generate color. We copy this one, include Windows H, a little hard to fast, create color, handle, maybe handle is better, and when you have this handle, it's better to use handle here. Handle, and here we take it color, and we're creating the static function set color. And now we're moving to the composite pattern, include instead of Windows H, we including the color H. Here we're calling color set color. One is blue, and now we need to change the leaf color. Able to use also include color, and you're calling static function set color like green. TV screen. Yes, and as you see, the leaves is a green color. The composite object is blue color. You see here the inspirant, peripherals, like other leaves, cabinet, motherboard, and etc. And if you need to display some different information, like not computer, you need to see the cabinet. We're running the cabinet and see what is added in the cabinet. In the cabinet we have motherboard and we have Intel i7 prices and we have Corsair RAM. Okay, if you need the peripherals, we're able to look the peripherals. Of course, able to create the different methods to filter this information, and you get like this. Of course, here's only details. And the final nowadays goal, I would like to create another method for the component to add virtual to calculate some price for some products of composite objects. Double show price. I know how to call this method because sometimes you need to show the price. Here it's like double, maybe it's more get price, maybe it's get price. We create the virtual double which returning price, and in leaf you should implement this function void get price override why it's not double, yes, double, and we need to implement this to return this price. Here it's basically that's it, getting the price. Yes, for the single leaf, for the single component, you're getting the price. For composite, you have the group of components, and you need first to implement get price and double get price override, of course, and Alt Enter to generate to implement this implementation added. And composite get price, you need to calculate first. You need to for components, be able to use auto keyword also if you need it. If you would like to use the auto, it's easier to use it. And as you see, it's really easy to use it later using auto, because you need to remember which type of objects in that list. Even using auto, it's really easier to use it. Component, and you need to calculate your total, double total, 0, 0, 0, F. Of course, you don't need if you know. And here you need to calculate total plus equals C dot get price. Just calculating your total price and you're returning total price. Our goal is finished here. We creating the get price for the composite. Composite is a group of objects. Leaf is single object. And now we try to test our implementation. and maybe I need to create different output, or we don't need to create different output. I'm not sure. Maybe we try in the main to create this cout std cout get, for example, peripherals dot get price. Your peripherals total price. Here we adding euro. Oh, sorry, euro and line, std and line, and your peripherals total price. Of course, we need std cout. Maybe we just copy this better. Your computer total price, and we get computer. And now we just printing different color. Set color 3. Header file, and here we just adding color. Set console color 9, for example. I'm not sure which color. And here, as we see, we're calling the get price method, which is calling peripherals get price and computer get price. And we get some information. As you see, as a teal color, you get peripherals total price is 420 euro. Here we see the output of peripherals. It's also 300 and 120. Yes, it's 420. Your computer total cost or total price, it's 1,120 euro. And it's really flexible composite pattern. When you have implemented a group of objects, you're able to do stuff like this. Of course, you're able to implement the same functionality without the composite pattern, but sometimes you need to do like this. And as we see, what you're able to do more, you're able to create another objects outside, and you're able to do anything with that pattern. You're able to create, like, I don't know, the book have chapters, paragraphs, and when you need to display the chapter, you're calling the chapter as a composite object, and when you need paragraph as a leaf, you're able to display, for example, leaf. And at the maybe today is enough, and if you have any questions about this topics or other topics, may you ask during the offline the stream, and ask maybe through the email, or try to write it in the chat or in the Moodle. And next week maybe we'll look into more details, and of course we'll look in your tasks, because now the situation is really hard to learn at home. It's hard, and to ask through a mail, of course, you're not able maybe to ask all questions, and I don't know which type of questions do you have. Maybe we ask through the mail. And I also tried during the streams to show all the tasks we need to done, like the task 3, maybe added more examples, and for task 1 is your own. Here is some example, and for other task maybe I try to prepare some examples how to implement using recursion next week, maybe not sure, or try to show another good stuff. And thank you for your attention today, and see you next week the same time, 9:30. And our goal during the practice or other theory lectures, when you're working at home, you just try to complete your tasks, and when you complete your tasks, send me just some email, and we try to look into your tasks implementations. Bye.